All right, hello everyone. So let's quickly talk about the Lab12. So first of all, in today's lab, we are going to study about the delts, and there are a couple of features you need to know for delts. The first of all is the non-linear components. So before, when you study about the resistor, capacitor, or inductor, they all follow the Ohm's law. So everything is linear. But for delts, if you plot the IV curve, is something like this. So it's not a linear plot. And then for delts, there is a forward and reverse region. The meaning of forward is you apply the positive voltage at positive side of your delt. Okay, so if you apply the negative voltage at the positive side, that's called reverse bias region. Okay, and then there is a turn on voltage. So there is not a specific voltage the delts will turn on, but usually we define the turn on voltage as at some voltage the current start to increase exponentially. So that's usually we call the turn on voltage. And of course, there's a breakdown voltage, which means if you apply a very large voltage across the delts, the delt will just break down. So if you check the lab kit you have, so the delt looks something like this. There is a little strip, so that thing indicates the polarity. Okay, so this side is positive, this side is negative, and this is the corresponding symbol on the schematic. All right, so in today's lab, you are going to play with these three delts, and they have different. They work similarly, but they have different features, like different turn on voltage, and this one have a reverse bias current. So you will find out what's the difference when you're doing the lab. And first of all, the task one. Uh, Simply, there are two questions, only two questions for task one. You only need to answer these two questions. So there is no conclusion and no objective in the write-up. Just answer these two questions. The first question is why you're using the differential amp to measure the voltage. So if you check the line menu, the circuit in the line menu have a differential op amp in here. So first of all, you want to know that the one of the function of differential op amp is that it can transfer a differential signal into a single-ended signal, and the the equipment in the lab room or the benchtop oscilloscope can only read the single-ended signal. So that's why in the previous semester, when we're doing this lab, you need a differential op amp transfer the differential signal to a single-ended signal, so that the benchtop oscilloscope can read the signal. But this semester, since you are using AD2, so AD2 can directly read the differential signal. Okay, so actually you don't need the differential op amp in here. And then the second question is asking about the mass expression for the op amp, I mean the amplifier. So this question is basically asking these two equations, okay? The G equal to what and the V naught or V0 equal to what. So we can simply find these two equations in the datasheet. Figure 1, there is a figure and they include these two equations, okay? So that's basically the task 1. Remember, there's no objective and no conclusion, no circuit diagram. Just answer these two questions. Okay, then for the second task, you're going to study. You're going to start to measure the IV curve. So what's the IV curve? Okay, so it's basically you draw the plot that the y-axis is the current cross your component, cross the component, and the x-axis is the voltage cross the component. So that's called the IV curve. Okay, so before you will build this circuit in the breadboard or on your breadboard, but before you build the circuit, you need to know what's the value of each component. Okay, so for the value, I mean the R limit and the R sense. So these two resistance is following this equation. Okay, so these two plus together is greater than the Vs maximum. So the Vs maximum is the maximum voltage at voltage source. So if you check the questions, the maximum voltage is 4 volt. Okay, and remember, the voltage source in here is an AC signal from -4 to +4 volt. Okay, so the frequency and the frequency and the shape of your signal is not required. You can either use a triangle wave or sine wave, but yeah, you can just use sine wave and set the amplitude to 4 volt. Okay, and then the VD test and the ID max. These two components is meaning the maximum current cross this delta. Okay, so if you check the question, the maximum current will be 30 milliamp. And then if you find the figure 12.5 on the line menu, this current is corresponding to a voltage about 0.9 volt. Okay, so that will be the voltage VD test. Okay, so then you can calculate this equation. So R limit plus R sense will a little bit should be greater than this 103 ohm. So if you check the question again, you want to choose the R sense from these three value, 10, 100, or 1k ohm. And if you realize, you can choose either 100 or 1k ohm. But what you want is this value, these two plus together, just satisfy the equation. Okay, so what it's meaning these two value, it should be just a little bit greater than this 103 ohm. So if you choose the R limit or R sense too large, you will limit the current too much. Okay, so if you use 103 ohm, this R ID max will be about 30 milliamp. But if you use like maybe 1k ohm, it may limit the ID max to maybe 5 milliamp or something like that. Okay, so you don't want that your IV curve have that small current. You want your current go about 30 milliamp. So you just choose the R limit and the R sense that just satisfy this equation. Okay, so after you choose the value for R limit and R sense, you can start to build the circuit. The circuit will be something looks like this. The voltage is from W1, the function generator, and you will use channel 2 to measure the voltage cross R sense. Okay, so 2 plus and 2 minus at two sides of R sense. And you will use channel 1, 1 plus and 1 minus to measure two sides of the delta. Okay, so after you get the circuit connect together, you can plot the IV curve, which you will use XY mode to plot the IV curve. Okay, so the plot will be something like this. Okay, for each different delta, the plot will be something like this, but a little bit different. The one thing you need to pay attention is, as I mentioned, the x-axis is the voltage cross the delta, so that will be channel 1. and the y-axis will be the current across the diode. Okay, so if you remember, you're using channel 2 to measure the voltage. So since you want the current, you will need a mass function. So it's simply the channel 2 divides the resistance of our sense. That will be the current. All right. So after you get this two plot, you will use the you will export the data to Excel. Then you can either use Excel directly plot the every curve, or you can use MATLAB to plot the every curve through the Excel. So it depends on you. So after you've done the first question, at the very last step, you will measure two. Okay, you will have two plot, two curve at one plot. The first curve will be single diode, and the second curve will be two diode in series. So the plot will be something like this. If you done everything correctly, so this is the curve for single diode, and this is the curve for two diode. And if you measure the voltage at 10 milliamp, the voltage for single diode should be half voltage of the two diode in series. Okay, so that's how you do the task 2, question 1. So how you can get the every curve, current and voltage curve. And then the rest of the task should be similar. You just replace the diode with the Zener diode and the Schottky diode. And the last question is asking what's the difference between three diodes. So as I mentioned, you can compare the difference from the 10 ohm voltage and for example, this one have a reverse bias current. Okay, so that's how you can describe the difference. All right, so that's task 2. Then the last task is task 3. So this one is simple, as long as you finish this 2. So one thing is you remember, in this task you need to plot the every curve for 1N4148 and 1N5226B. So in task 2, it's asked you to plot the every curve for 4148. I mean, export the data to Excel for 4148, but it doesn't mention for this diode. But actually, you do need to export the data to Excel so that in this task, you can plot the every curve for this two diode. Okay. So for this task is simply you need to plot the load line and these two diodes every curve in one plot. Okay, so should be something like this. Okay, first of all, what's the load line, or how you can plot the load line? So this is the circuit you will build, and the load line is simply, first of all, you find out the open voltage, also the VOC. When here is the open, what's the voltage at this circuit? So you find the VOC, and then you find the ISC, which is the short current. So when you short here, what's the current across this circuit? So you find this 2 point, you connect these 2 points together. This line is the load line. Okay, so then you plot the every curve for this two diode in one plot like this. The intersect point, that's the VD you will get from this circuit. Okay, so remember in here, this voltage source is a DC, so simply a 5 volt. And you measure the VD here, and you compare this VD with the plot the VD from the plot. So to see the difference, they should be close together. All right, I think that's all for the task for Lab12. Just let me know if you have any questions.